In this episode of Mr. Layman's Knowledge Explosion, we're going to talk about how to use the ratios of sine, cosine, and tangent to find missing sides and angles. So to start this, let's review how to set up the ratios with some angles that you should know fairly quickly. You'll notice that I drew a 45, 45, 90 triangle, and I'm asking you for the sine of a 45-degree angle. We know the basic numbers on a 45, 45, 90 are 1, 1, and the square root of 2. So the sine of 45 is going to be the opposite side of 1 over the hypotenuse, which is 2. So we're going to say that would be 1 over the square root of 2, which reduces to root 2 over 2. So that would be the sine of any 45-degree angle. The tangent of 45 would be the opposite side 1 over the adjacent side 1, or reduced to 1. So one number that most people remember is the tangent of 45 is always equal to 1 because that's a right isosceles triangle. We can do the same thing with a 30, 60, 90. So you see I've sketched a 30, 60, 90 with the sides of 1, root 3, and a hypotenuse of 2. And since we're looking at 30 degrees, if it helps, you can label this as the opposite side would be 1, the adjacent side would be root 3, and the hypotenuse would be 2. So the sine of 30 would be the opposite side of 1 over the hypotenuse of 2. So the sine of 30 is always 1/2. Now if I do the tangent of 60, you want to relabel these because the hypotenuse doesn't change, but the opposite side of 60 would be the root 3, and the adjacent side would be 1. So again, pay very much attention to that. So in this case, the opposite side over the adjacent would be tangent, so that would be root 3 over the adjacent side of 1, which reduces to root 3. So again, that's how we're setting up these ratios. Now we're going to use the idea in our next couple examples that says if the ratio for a certain degree angle measurement is always the same on every right triangle, how can we use that ratio to find a missing side? So here's a perfect example of exactly that. I have a 28-degree angle in this right triangle. The opposite side of that is x, and the adjacent side to that is 16. Well, if I were to write those two things, x and 16, as a ratio, that would be equal to the tangent of that 28-degree angle. But here is where I go to my calculator and I say, calculator, what is the actual decimal approximation for the tangent of 28? So I'll go to my calculator for that. This is a calculator where I can just write it. So the tangent of 28 is equal to 0.531. So I'm going to go back to my triangle and say 0.521 is equal to x over 16. And from here, this is like any other math algebra equation I've ever solved. I'm going to multiply this side of the equation by 16, which means I multiply both sides by 16. So on this side of the equation, on the right side, I'm going to get x, and on the other side, I need to take my tangent of 28, which is 0.531, and I need to multiply that by 16, which is equal to 8.507. So if that's equal to 8.507, then I'm going to round that to approximately 8.5. So for that ratio, again, this is the number that's important, the 0.521, which I think I got that wrong. I think it was 0.531. That's the number that's important. That ratio for a 28-degree angle is always 0.531. So I'm using that to figure out, well, what number must x be in the numerator so that that ratio comes out to 0.531. And the number that x has to be is 8.5. And that is the missing length of my triangle. So let's do another example. On the next example, Again, I have a 52-degree angle. X that I want to find is the hypotenuse, and 12 is the adjacent side next to that 52-degree angle. So if I just use the two parts, the adjacent side and hypotenuse, that would be a cosine relationship. So the cosine of that 52-degree angle is going to equal the adjacent side 12 over the hypotenuse of x. Now, I can go to my calculator and ask for the decimal right away, or I can just use cosine of 52 like a number. I know it represents a number, so let's just do the algebra first. To solve this equation, I'd have to multiply the right side by h to get 12, and that means I'd have to multiply the left side of the equation also by h. So to get h by itself, I would need to then divide by the cosine of 52 to get h completely by itself. Now remember, cosine of 52 is just a decimal. We're going to ask our calculator for that in a second. But the algebra gives me that h will be equal to 12 divided by the cosine of 52, which will be equal to 12 divided by, and here's where I'm going to go to my calculator and ask, what is the cosine of 52 degrees? So the cosine of 52 is 0.615. So if the cosine of 62 is 0.615, I simply use that ratio to finish solving for my hypotenuse, which in this case is x. So 12 divided by 0.615, so we're going to say 12 divided by that cosine of 52 is 19.491, or approximately 19.5. So that'd be 19.491, and that's where I'm rounding to 19.5. So again, we're going to use the ratio definitions with our calculator to come up with those missing sides. Let's do one more example together, but this time we're going to find the angle. Notice that in each example I start the same way. What is my angle? In this case it's x. I look and I notice that 8 is the opposite side and 21 would be my hypotenuse. Now, opposite and hypotenuse, it goes with the definition of sine. So the sine of that angle x is equal to the opposite side 8 over 12. So this example is slightly different. This time, I'm given that the ratio is 8 over 12. I could reduce this to 2 over 3, which would be 0.66 repeating. So I just have to ask the calculator a different way. I've been asking the calculator, what is the cosine of this 52-degree angle? What is the tangent of this 28-degree angle? Now I'm going to ask the calculator, what angle has a sine ratio of 0.6 repeating, or 2 over 3? Well, there's a specific button on your calculator, and it's going to look like this. It looks like sine to the -1. There's also a cosine and a tangent like this. This is called the sine inverse. An inverse just means the opposite. So it's going to give me the opposite of the sine. So if I give the calculator this ratio of 2 over 3, the calculator will tell me what my angle is. So we're going to write this, x is going to be equal to the sine inverse of 2 over 3. And when I type that into my calculator, it's going to tell me what angle has that ratio. Now my calculator is a little bit different since I'm using an iPad app here. Understand, sine inverse is the same thing as arcsine. So if you ever see that anywhere, sine inverse and arcsine, they're the same thing. So I'm going to use arcsine of my ratio 2 over 3, and this is simply asking the calculator what angle has a ratio for sine of 2 over 3, and that would be 41.8 degrees. So this angle is 41.8 degrees. And if we want to verify that, let's just go back and make sure on our calculator that the sine of 41.8 degrees is going to come out to 2/3. And look, there it is. So it's simply the inverse. It's like the addition is the opposite of subtraction. Sine inverse or arcsine is the opposite of asking the calculator what the sine is. Now if you notice in the upper left it says DEG for degrees. If I click on that and it says rad, radians is different. So when you're doing these sine, cosine, and tangent on your calculator, make sure your calculator says degrees, because everything we're working in is going to be degrees. If you're in Algebra 3 and you're doing radians like pi over 2 and pi over 3, that's fine. We're not going to do that in geometry. So make sure you're in degree mode. Let's make sure we have that idea. Plus I want to teach you the idea of what it means to be the grade of a road is 7%. This picture that I have drawn for you is the picture you're always going to draw for grade. Since percent is out of 100, what's that saying is the road is rising 7 units, 7 feet, 7 meters, whatever that is, 7 units for every 100 that I come across. So that makes a right triangle, and we're saying what angle does the road make with the horizontal? So we have a right triangle where I want to know this angle that's causing this hill in the road. Well, 7 would be the opposite side, and 100 would be the adjacent side. So the trig ratio that uses opposite and adjacent would be tangent. So the tangent of that angle should be equal to the opposite side 7 over the adjacent side 100. So here again I'm asking for the angle that has this specific ratio. That means I'm going to ask what is the tangent inverse of 7 over 100, and that's asking the calculator what's the angle that has that ratio. So going back to my calculator, I'm asking for the arctangent of 7 over 100. Remember, arctangent, same thing as tangent inverse, depends on your calculator. And it's telling me that that's 4.004, which means in our picture, x is a 4-degree angle. So that's how we use the ratios to set up an equation, and then we solve the equation and use the ratios that have been programmed into the calculator to finish solving.